All right, welcome to your recording for the Unit 7 through, or Activity 7 through 11 review for Unit 2. Please, I know I said it in class, but remember that the review sheet was just Activity 7 through 11. You have to also study Activities 12 and 13 because those are also part of Unit 2. So just going through here, a couple problems just to make sure we know what we're doing. Number one, we did countless problems where we were using a rectangle or three sides of a rectangle, but making the connection between perimeter and area. So in number one, the key here is that if the perimeter is 80, and we have a rectangle where we're using all four sides, you have the width and you have the length. So remember, if you're using all four sides and the total is 80, 2L plus 2W equals 80, which means that L plus W equals 40. So because you can only use one variable, it said write the function A of L. So that means you're only using L. So solve for L in terms of W. That means, oops, I just did that the wrong way, goofy me, minus L. So W equals 40 minus L. So that means the width is 40 minus L, the length is L, so L times 40 minus L is how I got my answer. Now on the answer sheet listed it in standard form because I kind of wanted it that way in order to graph it, so I distributed and put it in standard form. But here in number one, it didn't say it had to be in standard form, so if you left it like this, that is perfectly okay. Some people asked me how to graph. At this point, you should not be asking me that question. Make a T-chart. Now, because you've learned some things since we did this in number two, you could have also done opposite of B over 2A to find the vertex and then found the x-intercepts as well. But remember that a T-chart will always work when it's just a general graph the function. Notice that I labeled my axes. Again, it says graph, not sketch, so make sure you have exact points plotted. All right, 3 and 4 are factoring. I think that we've about beaten factoring to death. Number 3, just the key is you need to know that that's the quick type of factoring. What multiplies to 15 and adds to 8 is 5 and 3, which is why it's x plus 5 times x plus 3. On number 4, remember that we always look for GCFs first. Here, 49 is not divisible by 3 or 9, so I know there is no GCF. But after you look for GCFs, you should look for special products. This and this, both perfect squares. So you try it. Since this has 3 terms, you're looking to see if it could be a PST. So square root of 49x squared is 7x. Square root of 9 is 3. Sign of the middle is minus. And then I just need to check. Negative 3 times 7 is negative 21. Doubled is negative 42. So I know that it's right. Remember that if you miss looking for your difference of squares or your PST, you're wasting a lot of time having to do a box or split the middle, and time is important. 5 and 6 are solved by factoring. 6 is just a difference of squares, so factors into x plus 5, x minus 5, and then set each of them equal to 0. I am going to do number 5. When I look at it, 2x squared plus 7x minus 30 equals 0. I look at it first, look for GCF. 7's prime and 2 isn't divisible by 7, so there is no GCF. 2x squared does not have a perfect square root, so I know it's not a special product. So that means now I'm going to chart factor. So 2 times negative 30 is negative 60. I'm looking for what multiplies to negative 60 and adds to 7. Really important that you actually confirm these answers. So there are lots of things that multiply to negative 60. Maybe you try negative 10 and 6. Well, those add to negative 4. So that's not going to work. So try a different set of factors for 60. Maybe you tried 15 and negative 4. Those multiply to negative 60, but they add to 11. Notice that I'm closer, and it needs to be between. So factor of 60 between 10 and 15 is 12. So I try 12 and negative 5. 12 times negative 5 is negative 60. When I add them, it does give me 7. So these are my lucky winners, 12 and negative 5, which means you're either splitting the middle with these two values or using the box with those two values to factor. Or you could also guess and check to factor this as well. So this always goes in top left, this goes in bottom right. And these lucky winners are what go into the other boxes. The order of those is not important, but do make sure you take the sign and attach the X. So now it's just GCF of row and column. So row 1, the GCF is 2x. Row 2, the GCF is negative 5. Column 1, the GCF is x. And column 2, the GCF is 6. So this is indicating that it should be 2x minus 5 times x plus 6. Take the time to double check it. 2x squared minus 30. So firsts and lasts are correct. Inners and outers, insides negative 5, outsides positive 12, which does give me positive 7. So I know it's right. So now don't forget to solve just because you factored. It's solved by factoring. So set each factor equal to 0. Here add 5 and then divide by 2. So x equals 5 halves. Here I just need to subtract the 6. So x equals negative 6. So put an or between them, and there is my answer. Number 7, I'm not going to work all of that out for you. I will kind of set up the beginning part. If you know that x equals 3/4 is a solution, multiply both sides by 4, 4x equals 3, then subtract the 3. That means 4x minus 3 is one of your factors. You can do the same for x equals negative 2/3. Multiply by 3, 3x equals negative 2, then add 2 to both sides, gives me 3x plus 2, and those equal 0. So the last step is you need to FOIL this. That's how I got my final answer. I'm not going to work out the FOIL for you. You should be able to do first, outside, inside, lasts, multiplying, and combining like terms to get the answer. Number 8, solve the quadratic inequality. The key is inequality. It's not an equal sign, which means some of you factored it, x plus 6, x minus 3, and that's great, and you wrote x equals negative 6, x equals 3. But this isn't an equal sign, so these are not your answers. Your answers, you can't just slap the symbols on here. That's not how it works. Remember that you have to show either a number line or a picture to get your solution. So this parabola opens up, and these are its x-intercepts, negative 6 and positive 3, so it looks something like this. You don't have to draw a graph, just a rough sketch because it's part of your work. Greater than 0. The part of this parabola greater than 0 is here and here, because that's the part bigger than 0 above the axis. Whenever the arrows are the part that you color based on this symbol, that means with these two x-intercepts, you're going to write an or. So either x is less than or equal to negative 6, or greater than or equal to positive 3. Remember, if you're doing the number line instead of this, you would put negative 6 and positive 3 on the number line, and you would pick points. So I would pick a point less than negative 6. So let's say I picked negative 10. Negative 10 squared is 100. 3 times negative 10 is negative 30 minus 18. So 100 minus 48 is 52. Is 52 greater than or equal to 0? Yes, it is. So I get a yes here. Between negative 6 and 3, I would probably pick 0 because it's the easiest to plug in. So that gives me 0 plus 0 minus 18. Negative 18 is not greater than or equal to 0, so this gets a no. And then something bigger than 3, maybe I pick 4. 4 squared is 16, plus 3 times 4, which is 12, minus 18. So this is 28 minus 18, so 10. 10 is greater than 0, so I get a yes, which means, again, if it's yes, no, yes, it's an or. So either the number line or this sketch needs to be a part of your work. Nine, I'm not going to go over. You just need to distribute the negative and combine all your like terms. Make sure that it's in the form a plus bi. 10, it needs FOILed. And then remember, you turn your I squared term to a -1 and combine like terms. The one I'm going to do is number 11 because it kind of has all of what's in 9 and 10 in it. So first thing we did here, writing the original. I'm going to get a different color here. So, in order to divide, I have to get rid of the i's in the denominator by multiplying by the complex conjugate. It's not the same thing as whatever this denominator is. You have to change the sign. So I'm going to multiply top and bottom by 4 minus I. So the reason I chose to do this one is because it's like the other two all rolled up into 1. I need to FOIL on this top. So 2 times 4 is 8. Outsides gives me -2i. Insides gives me positive 12i, and lasts gives me -3i squared. On the bottom, firsts, 4 times 4 is 16. Outsides give me -4i. Insides give me positive 4i, and lasts gives me -i squared. So now I need to turn my I squareds into -1. So now, -3 times -1 makes this a +3 term. Minus -1 makes this a +1 term. So I have +1 to combine with a positive 16. So that gives me 17. Here, these drop out. They cancel each other. Up here, 3 and 8 is 11. -2i plus 12i is 10i. Now, final step is what some people forget. It says write your answer in the form a plus bi, so you have to separate the real part, 11 divided by 17, which doesn't simplify, from the imaginary part, which is 10 over 17i. So make sure you don't forget that. A lot of people forgot that on the quiz. 12 and 13, solving by finding square roots. The key on these is the squared term has to be alone first. So in 12, you have to add the 8 and then multiply by the reciprocal to get x squared all by itself before you can take the square root. In 13, the squared term is your x minus 2 squared. So if I'm trying to get this whole thing alone, that means I need to get rid of this -4 by adding. So that gives me -48. Then divide by the 3. Again, you have to get it all by itself. X minus 2 squared equals -16. Now that the squared term is all alone, I can square root both sides. Don't forget to put in your plus or minus. Square root of -16 is 4i. And then add the 2. So 2 plus or minus 4i. Was my answer there. All right, 14, solve by completing the square. I'm going to go over completing the square again in number 24, so I'm not going to go over it twice. So if you messed up on completing the square, make sure you look at what I do for number 24 because that's the process you should be following to solve 14 as well. 15 and 16, find the discriminant, tell how many and the type of solutions. I'm not going to go over those either, but do remember that the discriminant is b squared minus 4ac, and you have to know your chart. And in the 1213 review video, I go over the chart and write it out again. So if you feel like you don't know it and you need to hear me explain it, then you should go check out the 1213 review video to hear all of that again. Number 17, quadratic formula. The key here is that you can't use the quadratic formula until it's equal to 0. So I have to add x squared, minus 2 to get 5x squared plus x plus 1 equals 0 before I can use the quadratic formula. So then it's opposite of b, plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. So simplifying this, 4 times 5 times 1 is 20, so 1 minus 20 is negative 19. And then because this is negative, you bring out the I. This one you got off kind of easy because there wasn't a lot to simplify. Because there was nothing you could do to break down radical 19, and there were no common factors to reduce, so that is just the answer. 18 through 20. If you had a lot of trouble with this, again, in this review video, I can't do all the problems. If you had a lot of trouble with this, you need to go back and watch the 10-11 review video because I do this in much more detail in those. But the key for 18 through 20 is knowing these. There's 2 of them, remember. These are the conic form parabolas. Remember that you have to know that if it's negative and the y is alone, it opens down. If it's positive and the y is alone, it opens up. If the x is alone and it's negative, it opens left. If the x is alone and it's positive, it opens right. You have to know that. There's no way you can do these problems without that knowledge. Really important that you have that memorized. P, remember, is the distance from the vertex to the focus and from the vertex to the directrix. So you need that as well. So in number 18, the formula that they gave you was 1 over 4x plus 3 squared minus 1. So you should immediately find the value of p. So since 1 over 4p equals 1/4 in this case, you know that the only way for this to be true is if p equals 1. So write down p equals 1. You should also immediately be able to figure out which way it opens because the y is alone and it's positive, so that means it opens up. My vertex, since the parenthesis has the x in it, that means that the x coordinate of the vertex, I changed the sign, so -1. Y coordinate keeps its sign, or -3 here, and -1 for the y. Axis of symmetry, because it opens up, that means the axis of symmetry is a vertical line, so x equals the x coordinate of the vertex. The focus, here is where you need p, and I would do a little sketch. If my vertex is at -3, -1, and I know p is 1 and it opens up, that means I go 1 unit up to get my focus. That also means I go 1 unit down to get the line where my directrix is. So when you draw that sketch, now you can see where the focus is. At -3, 0, the directrix is the line, y equals -2. Make sure you don't write it as a point, it's a line. 19 and 20, again, you're doing the same thing. I'll do number 20. This one was, so the focus was -3, 0, and the directrix was y equals -2. So this was number 18. Number 20, when the focus is 0, -4, so 1, 2, 3, 4, and the directrix is y equals 4. So you know that this opens down because the focus has to be on the inside. Directrix can't touch the parabola. You also know that the vertex has to be halfway between. So halfway between those two values is actually the origin. So you know that your vertex is at 0, 0. So I also can calculate the value of P because it's the distance from the vertex to the focus or from the vertex to the directrix. P equals 4. So now it's just a matter of plugging those things in. If it opens down, I know that the y is alone. So y equals, I also know that it's negative since it opens down, 1 over 4 times P, 4 times 4 is 16, times x minus h squared plus k. So h and k in this case were both 0. This will need simplified. You can't leave zeros that you don't need. So it's just going to be 1/16 x squared, and that is your answer. Number 21 is the one that I messed up when I forgot to edit my table because I am not always the smartest. So remember that what you're doing on problems like 21 is you're looking at the table. If there is a constant rate of change, which is what I meant to do when I forgot to edit the table that I had. So when there is a constant rate of change, that means it's linear. So what I had intended to do on that table was change the values so that they all went up by 11. I forgot to do that, which is why this was probably confusing if you did it ahead of time. So if it's a constant rate of change, it's linear. If you can see a turning point where it goes increasing to decreasing or vice versa, was decreasing and now it's increasing, then you're going to know that it's quadratic. And if you can't see either of those, then you can't say what type of model would be a better fit. So again, I intended for the table in 21 to be linear. I just forgot to edit it. Now the way it was as is, you really couldn't say whether it was going to be linear or quadratic. I guess you would have picked quadratic because the rate of change isn't constant. Now, I intended it for it to be linear, so then 22, to find the equation of best fit. If you choose linear, then you're going to run a linear regression. If you choose quadratic, then you're going to run a quadratic regression. All right. 23, I'm not going to go through all of the steps because the answers are the answers. You should know the transformations by now. I had a couple people on the quiz try to write as a transformation opens down. Opens down is not a transformation. That's something we use to help us graph it. The transformation that causes it to open down is a reflection in the x-axis. So make sure that you're not writing opens up, opens down as a transformation. You can write that to help you graph it, but it's not a transformation. The part I am going to do is the graph, because as you're looking at it, you should be able to see that the vertex is at 1, 5. So I go right 1. And up 5, those were some of the transformations you should have listed, right? 1 up 5. You always start with plotting the vertex. Then you see that since it's reflected, that means that it opens down. And because this one had a vertical shrink of 1/3, that means typically in my parent graph, I would go left and right 1, down 1, left and right 2, down 4, 3, 9, 4, 16, so on and so forth. I'm going to be multiplying all of those by 1/3 because that's the vertical shrink. So again, it's up to you whether you want to plot fractions or whether you want to keep going till it comes out evenly. I don't care which one you do. So if you go left and right 1 and down 1/3, so just a tiny, tiny bit, then left and right 2, down 4/3, which is 4 times 1/3. So 4/3 is 1 1/3. So right 2, down 1 1/3. Left 2, down 1 1/3. That would be enough points if you're plotting fractional pieces. If you aren't plotting fractional pieces, then you would wait till this one where you go left and right 3, down 3. So left 3, down 1, 2, 3 would be over here. and over here, and then you would wait till 6, where you would go left and right 6 and down 12 if you were waiting for ones that came out evenly. But again, it's not just any random points, and you're doing this on the non-calculator version, remember, so you can't use your calculator to help you. So make sure you know how to multiply by the amount of vertical shrink or stretch to get the exact points other than the vertex. You can't just connect it and make it open down. You're going to lose points because the exact points have to be plotted. All right, 24, I told you I would do this one to illustrate completing the square, because that is how we write something in vertex form. Your work has to be shown, so you need all of the steps. So the first thing we do here is we take out our h of x and we replace it with a 0. And then we want our constant on the other side. So on number 14, you also need to move the constant to the other side as your first step. So here I'm going to move the 7. I'm also going to write it the other way. So I'm going to write negative 2x squared minus 4x equals 7. Next step, after you move the constant, is to factor out the coefficient. So I'm going to factor out a negative 2. It's always whatever this is. Don't try to just make it like a GCF type thing. It's not a GCF. It's whatever this number is, that's what you factor out. So factor out a negative 2. That gives me x squared plus 2x. Remember, you can redistribute to check if you want. And then I'm going to leave blanks on both sides. So you fill in the blank when you complete the square. On 14, by the way, there was nothing to factor out, so you get to skip directly to putting the blanks there. We fill in the blank with b divided by 2 squared. So 2 divided by 2 is 1, 1 squared is 1. And so on 14, 8 divided by 2 is 4, 4 squared is 16. So 16 was the value that completed the square on 14. Now, to complete the square on the right side, remember you need to do your little swoopy multiplying. Negative 2 times 1 is negative 2, so that's the value that completes the square on the right. In number 14, since there was nothing to factor out, you don't have to multiply, so in that case, the blanks on either side are the same. So now I need to factor my left side as a PST. This is x plus 1 squared. Remember, square root the front, sine of the middle, square root the back. On the right side, 7 plus negative 2 gives me positive 5. And now I just need to put it back in function form. So I need to move my 5 over by subtracting it and put my k of x, or oops, in this case h of x, back in front. So h of x equals negative 2 times x plus 1 squared minus 5. All right, 25. Remember, this is on the non-graphing calculator part, number 25 is. So really important that you are doing this by hand and not with your calculator. Fill in the appropriate information, then graph the quadratic equation. So first thing it wants is the vertex. So we do that by doing opposite of b divided by 2a. So opposite of negative 8 is positive 8 over 2 times negative 2. So 8 divided by negative 4 is negative 2. So the x-coordinate of the vertex is negative 2. I plug it in order to find my y-coordinate. So again, you can use your calculator to help you if you want. Negative 2 squared is 4. Negative 2 times 4 is negative 8. Negative 8 times negative 2 is positive 16, and then minus 5. So negative 8 plus 16 is 8. Minus 5 is 3. So that's how I got my vertex at negative 2, 3. Once I have my vertex, I should know my axis of symmetry because I know this opens down. So the axis of symmetry is the vertical line through the vertex, so x equals negative 2. I also should know, because I know generally what my graph would look like, that it opens down, that it's going to be increasing when x is less than the x-coordinate of the vertex, because that's when it's going up as we move from left to right, and when it's decreasing, meaning as I move from left to right it's going down, that means it's going to be from the x-coordinate of the vertex and bigger. So that's why I wrote x greater than or equal to negative 2. Now, y-intercept. Remember, I find the y-intercept by plugging in 0 for x. So that gives me 0 minus 5, which is -5. Remember to list it as an ordered pair. 0, -5 is my y-intercept. The x-intercepts, remember I have to plug 0 in for y, and I have to solve it. So I have to solve this quadratic. So there is no GCF. It's not a special product. To see if it were factorable, I would be looking for what multiplies to 10 and adds to -8, which 2 and 5, 1 and 10, nothing. So it's not factorable, which means I either need to complete the square or use the quadratic formula. Because a is not 1, I'm probably going to go ahead and use the quadratic formula. So opposite of b, plus or minus square root b squared minus 4 times a times c, all divided by 2 times a. So simplifying, 1, 2, 3 negatives, which means it's going to be a minus. So 64 minus 4 times 2 is 8, times 5 is 40, over -4. So 64 minus 40 is 24. Now this square root, don't get off as easily as I did in number 17. This I need to simplify, so either do biggest perfect square or factor tree. So it's 4 times 6. 4 is 2 times 2. So that means a 2 gets to come on the outside. 6 is 2 times 3, but nobody has a date, so the 6 has to stay inside. So I've got 8 plus or minus, again, a 2 got to come outside, so 2 radical 6 over -4. Now, final step, all 3 of these are divisible by 2. So that gives me final answers for x-intercepts when I divide by 2 is 4 plus or minus radical 6 over -2. And then remember they're ordered pairs. I just listed them together with the plus or minus. Certainly you could list them separately. There are 2 x-intercepts. So that gives you all the points you need to draw your graph. So I know that my y-intercept is at 0, -5. So I put that on my graph. I know that my vertex is at -2, 3. So I plot that. This guy, I know that radical 6 is somewhere between 2 and 3 because it's between the square root of 4 and the square root of 9. So somewhere between 2 and 3. So let's just use 2.5 as an example. 4 plus 2.5 is 6.5. Divided by -2 gives me -3 and a little bit of change. So when I'm plotting that x-intercept, it's a little past that. So that gives me a point to the left of the vertex. So then I can connect my points to get my graph. All right, very last thing, 26. I'm not going to do it, but I'm going to remind you how. It gives you the h equals -16t squared plus 70t. This is a real life situation and you're allowed to use your calculator. So into your y1 you should be putting this. Once you put this into your calculator, you should be able to adjust the window and find a graph. And you get something like that-ish. It opens down. The maximum height of the boiling water, that's second trace, choice 4, because that gives you the maximum. So you do second trace choice 4 to find the vertex. The y coordinate of the vertex is the maximum height. Don't forget your label of feet. What time the boiling water reaches the maximum height, that's the x coordinate of the vertex. So you don't have to press in anything new. It's just the x coordinate, which is 2.2 seconds. And then how long is the boiling water in the air? That's the second x-intercept. That's right here. So you have to do second trace, choice 2 for 0 to find the x-intercept there, which is the x-coordinate there is 4.4. So 4.4 seconds is how long it's in the air. All right, that wraps up some examples of all the different things you need to be able to do in activities 7 through 11. Remember again that activities 12 and 13 are on the test, so if you need to, go back and watch the 12-13 review video. Certainly there are the 7 through 9 and 10-11 videos that could be helpful as well. Happy studying!